All right, here goes number 4. We're doing just number 4 here. Yeah, that number 4, the one that's really long, that's this one. So we'll kind of take care of this step by step here, talking about the picture that we see and what's going on, where we have a machinist that drilled a conical hole, so it's shaped like a cone, into a cube of metal as shown. It's pretty clear, right? There's the picture. If the cube has side lengths of 7, what is the surface area of the metal solid in square centimeters after the hole is drilled? And we're going to use 3.14 for pi, and we're going to round our answer to the nearest tenth. Makes sense, right? I think the hardest part of this problem is kind of identifying exactly what's happening. So we have a cube, and we're going to find the surface area of this cube. So let's do that. Let's just find the surface area of the cube. The surface area of the cube is going to be 49 times 6. Why 49? Because 49 is the area of each face of the cube. Ignoring the cone, 49 is the area of each face of the cube. So this is 49, this front face here, if you can kind of see that. This side face here is also 49, as is the top face and the bottom face and the side face and the rear face there. And how do I know that? Because the cube has side edges of 7 centimeters. And if it's a cube, all of the side lengths are the same. So one face has an area of 49, therefore all of the faces have an area of 49, and there are 6 altogether, which gives us an area of 294. This here is the surface area of the whole cube. So if that was the question, we would be done. But that's not what's happening here, because now a hole in the shape of a cone is being drilled into the cube. So what I'm going to do here is find the area of this circle right here, because what was a part of the cube is now gone. This circle now doesn't exist and is no longer a part of the surface area because it's gone. It's been drilled out of there. So what I'm going to do is pi times 3.5 squared. Where does 3.5 come from? 3.5 is the radius of this circle. While it's not obvious and would be a good question to ask, the radius of this circle is 3.5 because this end all the way to this end is 7. Like that circle does touch the edges of the cube. So the radius of this circle is 3.5. So that means that the area of this circle that has been drilled out of the cube is going to be pi times 3.5 squared, which is 38.465. This number right here is the area of the circle that has been removed from the cube. But when we remove that circle, all of a sudden there's this area now on the inside of the cube that is the lateral area of the cone. So now what we have to find is going to be the lateral area of the cone. And here, what I've done is now taken this area of the circle and subtracted it from the cube. So I kind of jumped ahead of myself a little bit there. This subtraction right here is, this was the area of the cube, but then we cut out the circle up top. So this is currently the area, the surface area of the cube with the circle missing. But with the circle missing, there's this other area around the side, which is the lateral area of the cone, which we have to find. So now this is the area of the cube minus the area of the circle, and now we can go find the area, the lateral area of the cube, of the cone, which is going to be 1/2 L times P. That's pretty straightforward, right? No, that's not straightforward at all. So this lateral area of a cone is a problem in and of itself. So right now we're sitting at 255.535. That right now is the area that we have. Area of the cube minus the area of the circle, but then we have this other area that we have to account for that now exists after this cone has been drilled in. So let's talk about this right here, the lateral area of the cone. 1/2 L times P. The L stands for the slant height. It's the slant height of the cone. And what the slant height of a cone is the distance from the tip of the cone all the way down to the bottom edge of the base of the cone. And the P is the perimeter of the base of the cone. The base of the cone is a circle, and the perimeter of a circle is called circumference. So I need to know the lateral, or the slant height, and the perimeter. What's this, you say? That is the Pythagorean theorem. Why is the Pythagorean theorem on the screen? Because I need the Pythagorean theorem to find the slant height of the cone. Because now if we visualize right here, we don't know this length from the tip down to here. We don't know this at all. But we do know straight up is 7, because we know that each edge of the cube is 7. So this is 7 right here, and then from here out to here is going to be 3.5. The radius of the circle is 3.5. And then what's formed there, what I'm forming right here, is a right triangle, and I know two of the side lengths, 3.5 and 7, and then I'm missing this value right here, which is the hypotenuse, which is c. So I'm going to use the Pythagorean theorem to find out what this slant height is, because I can't find the lateral area of the cone if I don't have the slant height. So that's what I've plugged in right here. This is what I'm going to evaluate. So I get 49 plus 12.25 is equal to c squared. 61.25 then equals c squared, but I don't want to know what c squared is. I want to know what c is, so I have to take the square root. So c is 7.83. Well, what's the significance of 7.83? 7.83 is the slant height of the cone. So now I know the slant height by using the Pythagorean theorem. Now I have to find the perimeter of the base of the cone, which is the circumference of the circle. And I can do that because that is 7 pi, because the radius is 3.5. And the circumference of a circle is 2 times pi times the radius. 2 times 3.5 is 7. So now this will give us the lateral area of the cone, which when I simplify that, I get 86.05. So the lateral area of the cone now is what's been added in to the cube. This is now surface area that exists after we drill that hole. The hole's been drilled, and all of a sudden there's this cone-like figure inside the cube, which is now more surface area that we have to account for. So we have to take this 86.05 and add this onto our current surface area. So we're going back. So this right here, well, on the screen, 294 minus 38.465, this right here is the area of the cube minus the area of the circle up top. Then we found the lateral area of the cone, and this is more area now that needs to be added because there's more surface area. So we're going to take that 255, add in the lateral area of the cone, and get 341.585. So now that we have 341.585, we can go 341.6 because it says round to the nearest tenth, and the surface area of this cube with a cone drilled into it is 341.6.